Okay, in this video we're going to be learning about the rational root theorem. We're going to actually skip this activity. If you have my notes, we're just going to jump right down here. Here's the definition of the rational root theorem. What it's going to do is it finds all the possible rational roots of the polynomial. The key here, it does not find any irrational roots. Because it's called the rational root theorem, it's finding out what rational roots. Just to review, a rational number is a number that can be written as a fraction. So it's going to give us those roots, but it's not going to give us the irrational roots. And also it gives us what we call all the possible roots. It doesn't mean that it's going to be the actual roots. I like to think of it as candidates. So it's going to give us all the possible candidates for possible solutions for our polynomial, but it won't give us the exact ones. We have to do a little digging and do a little weeding out to take all those candidates and get them down to any of the actual rational roots. So first off, here's what you need to understand about the rational root theorem. It's represented by this p divided by q, where p is a root of the function in lowest, or that equation is always going to be a fraction in lowest terms, where p is going to be a factor of the constant and q is going to be a factor of the leading coefficient. So p is going to be a factor of the very last term, the constant in the equation, and q is going to be a factor of the leading coefficient, the first coefficient of the polynomial. Here's what I mean by this p divided by q stuff. Let's look at this example. It says, apply the rational root theorem to identify the possible rational roots of the function when we're given this equation. 4x to the fourth plus 3x cubed plus 4x squared plus 11x plus 6. So to find all the possible rational roots, what I want to do is this. I want to set this up as my p over q. Remember, p is p is the factor of the constant. So our constant in this case is 6. So we want to list out all the possible factors of 6. Well, we would have 1, 2, 3, and 6, because 1 times 6 is 6, 2 times 3 is 6, but we have more. We could have a negative 1 and a negative 6. I could have a negative 2 and a negative 3. So the way that we write this is positive negative 1, positive negative 2, positive negative 3, positive negative 6. Now, q is going to represent the factors of the leading coefficient. So the denominator here is going to be the factors of 4, which would be plus or minus 1, plus or minus 2, or plus or minus 4, because 1 times 4 is 4, 2 times 2 is 2, and we can have negative 1 times negative 4, and a negative 2 times a negative 2 would all give us 4. Now remember, this is a ratio of p over q, so all of these, so in other words, my numerators for all my potential rational roots, my numerators would be the 1, 2, 3, and 6. My denominators for the possible rational roots would be 1, 2, and 4. So what we're going to do is we're going to set up all the possible fractions that I could get with these as my numerators and these three numbers as my denominators. So I'm going to start out with just focusing in on the 1 in my denominator. So I'd have 1 over 1, 2 over 1, 3 over 1, and 6 over 1. There'll be positive and negatives of each of those. Because these are all having 1 as my denominator. So now I'm done with 1 as my denominator. So I'm going to focus on 2 as my denominator. Now remember, it's in the lowest terms, so we want to reduce these. And if I already have it listed after I reduce it, I don't need to list it again. Here's what I mean. We start out with 1. 1 over 2 reduces to just stay 1/2. 2 over 2, that reduces to 1. I already have 1 listed, so I don't need to list it again. 3/2, that doesn't reduce, so it'd be plus or minus 3/2. 6 over 2, well, 6 over 2 reduces to be 3, and I already have 3 listed, so I don't have to list that again. So now I'm going to go to the 4 as my denominator. I want to list out all the possible roots now that would have 4 as my denominator. So 1/4. 2/4 reduces to 1/2. I already have that down. Plus or minus 3/4. And that's it, because 6/4 reduces to 3/2. We already have that. So these are all what we call the possible rational roots. Now we want to figure out which ones out of these. Now there's a total of 16. You might say, well, there's 8. No, there's plus or minus for each of these, because we have 1. So in other words, plus or minus 1, so that's 2, 4, 6, 8, 10, 12, 14, 16. So I have a 16 total possible. So these are all my candidates. I want to figure out of those candidates, out of those 16 possible ones, which ones are actual rational roots. So I'm going to, if you have my notes, oops, copy these and put them down here in this next problem, because in this next problem, that's what they're asking us to do. We're going to figure out, find the actual roots here. So to do that, we're going to need our graphing calculators. Oops. There we go. So what we're going to do is we're going to graph out this equation. So go to a calculator screen, and we're going to graph the equation for 4x to the fourth. Remember, this is an exponent, so you need to move the cursor back down. Plus 3x cubed plus 4x squared plus 11x plus 6. Now sometimes in your assignments you might see a graph and it might look like it only intersects once. So sometimes it's helpful to know how to zoom in. So let's look at how to do that. So that way you can make sure that you're getting all of the potential intersections. So if you go to zoom in, you'll get this magnifying glass, and every time you hit enter, it'll zoom in at that spot. So we can see here that between 0 and -1, because if I look at this, here we're coding by 0.1, so this would be 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, so 1 hole. So this is one of my zeros, looks like it's going to be at 1 hole, and one that's going to be less than that. So here's what I'm getting at. Let me change my screen settings so we can do something here. So I know that my solutions are going to be between 0 and -1. So anything that is not between 0 and -1, I'm going to eliminate, because it is not going to be one of my intercepts. So the ones I'm going to try, and the positives I don't have to worry about, so I'm going to try putting -1 in this function. I might try -1/2, but it looks like from the graph, let's look back at the graph again. If this is -1, 1/2 isn't going to be a solution, 1/4 isn't going to be a solution, so I can eliminate, whoops. So I can eliminate 1/2 and 1/4. Let's just focus on these two. Again, the reason why I can focus on these two is because I know that it's between 0 and -1, and from the looks of it, it's even greater than -1/2. So I can eliminate -1/4 and -1/2 from the mix. But I can't eliminate -3/4. And -1, it looks like it intersects there, so we want to verify it. So here's how you're going to verify that. Go to your calculator again. This time go to a calculator screen. And we're going to type in the equation, except for this time we're going to replace x with -1. So it's going to be 4, and then parentheses, -1, parentheses to the 4th power. Move the cursor back down, plus 3, and then parentheses, -1. And this is going to be cubed. Move the cursor back down, plus 4x squared, whoops, plus 4, and then in parentheses, -1. Remember to always put these in parentheses because they're going to be negative numbers in this case, so it's always best just to use parentheses so you don't have to worry about trying to remember or not. So plus 4x squared here, so plus 11x is my next one. So 11 times -1, and then plus 6. Hit enter, and sure enough I got 0 as my answer. So that tells me that -1 is one of my roots. So now I don't want to have to retype all this in. That can be kind of a pain. So I'm going to hit the up arrow twice and hit enter. So that copies and pastes it down now so I can edit this. And I'm going to replace, instead of -1, we're going to put this in as -3/4, because I want to see is -3/4 a root. So I'm going to do that with all 4 of these -1s. Hit enter, and sure enough I get 0 again as well. So that tells me that my 2 roots are going to be -1 and -3/4. Now, it does occur sometimes where maybe only one of these works or none of them work. Well, all that means is that you didn't do anything wrong. It's just that, remember, this is the rational root theorem. So that tells us that it gives us the rational roots. So sometimes, remember, it could our intercepts could be at irrational locations. And so in that case, maybe some of your answers don't end up being 0 as your answer. That's okay. But in this case, both of our x-intercepts end up with zeros when we use the rational root theorem. So that means my solutions, my solutions here are -1 and 3/4 because they both equal 0. Okay, let's look at your assignment. So if you haven't done so already, you'll want to print that out or get that out. But in this assignment, it starts out by asking us these questions. It says, determine whether the rational root theorem, or according to the rational root theorem, if each number could be a root of the polynomial with the given first term and constant term. So let's look at a couple of these examples. So remember, we're looking at the rational root theorem is P over Q, where P represents the factors of the constant, and Q represents the factors of the leading coefficient. So they give us the first term is 2x to the 7th. They give us that the constant term is 6. So that means my constant is 6. My leading coefficient is 2. I want to see if each of these are factors using the rational root theorem. So 2 is the same as 2 over 1. So I'm going to try 2 to make sure that 2 is a factor of 6. The way that I can test that is, see, does 2 go into 6 evenly? Yes, it goes in there 3 times without any remainder. 1 goes into 2 evenly. So the fact that both of those divided into their corresponding parts correctly, or with evenly I should say, tells us that 2 is a potential root using the rational root theorem. So would -1, because -1 is the same as -1 over 1. -1 goes into 6 evenly, 1 goes into 2 evenly, so your answer would be yes for this one. 3 is the same as 3 over 1. 3 goes into 6 evenly, 1 goes into 2 evenly. Again, you don't care if 3 goes into 2, you're only pairing up 3 with the constant, you're only pairing up the 1, the denominator, with the leading coefficient. So this would be yes. This would be yes as well, because if I put -6, -6 goes into the constant 6 evenly, and 1 goes into the leading coefficient 2 evenly. So your answer would be yes. Let's look at number 3. Number 3, -7, is the same as -7 over 1. -7 does not go into 3 evenly, so I can stop right there and say no. Even though 1 goes into 14, it doesn't matter. They both have to be answered by yes in order for that number to be a possible root using the rational root theorem. Let's look at the next one. -1/3. This time they give us a fraction. So this is your P and this is your Q. So the 1 relates to your constant. So 1 goes into 3 evenly. 3 goes into 14. No, it doesn't go into 14. So your answer is no for this one. This one they don't give you a fraction. They give it to you as 3 over 1. So 3 goes into 3 evenly. 1 goes into 14 evenly. So this would be yes. This one they do give you a fraction. So we test 3 with the constant. 3 does go into 3 evenly. 7 does go into 14 evenly. So your answer would be yes for this one. So that's an easy way to go through and do that first part to see if these are possible roots. The same thing works for the second part. It's just that now they're giving us the whole function. They're asking us whether or not 2/3 is a possible rational root for this whole function. But remember, you don't need to worry about the middle term. All we care about is if 2 goes into 18 evenly, which it does, and whether 3 goes into 3 evenly, and it does. Your answer would be yes. But just because A is yes doesn't mean that B is going to be no. These aren't multiple choice. It's not one or the other. It could be one or both or neither. So let's look at the next one. 2 goes into 8 evenly. 3 goes into 6 evenly. So your answer would be yes for 7B. Now, in your assignment, number 10 and number 12 are just like what we did in class. I'm going to have you skip 11 and 13 and also number 14. If you haven't caught that already, you don't have to do those 3 problems. 11, 13, and 14 you don't have to do. So with that, good luck on your assignment.